The Numbers Channel, Understanding the Golden Ratio. Imagine a number so special that it appears in art, nature, and even in the way buildings are designed. That number is called the Golden Ratio, and it has fascinated mathematicians and artists for centuries. Today, we're going to look at how this number is calculated, why it's so important, and how it connects to patterns and sequences of numbers. The Golden Ratio is often represented by the Greek letter phi, which looks like this. Its value is approximately 1.618. The key idea is that if you take two quantities, a and b, where a is larger than b, then the ratio of the sum of a and b to a is the same as the ratio of a to b. This means a plus b divided by a equals a divided by b, and both equal letter 3d5. When you write this out as an equation, it looks like this. A plus b divided by a equals a divided by b, which equals letter 3d5. If you do some math, you can turn this into a quadratic equation, which is letter 3d5 squared minus letter 3d5 minus 1 equals 0. Solving this with the quadratic formula gives us letter 3d5 equals 1 plus the square root of 5 divided by 2, which is about 1.618. The negative solution isn't used because ratios involve positive numbers. An interesting property of the Golden Ratio is that it can be written as 1 plus 1 divided by letter 3d5. This means you can find letter 3d5 by starting with 1, adding 1 divided by letter 3d5, and repeating the process. It's a self-referential idea that makes calculating letter 3d5 simple once you understand the pattern. The Golden Ratio is closely linked to the Fibonacci sequence, a series of numbers where each number is the sum of the two before it. The sequence starts with 1, 1, then 2, 3, 5, 8, 13, 21, and so on. As the numbers grow larger, the ratio of one number to the previous one gets closer and closer to 1.618. This shows how the Golden Ratio naturally appears in number patterns. Beyond math, the Golden Ratio shows up in many places in nature and human creations. For example, rectangles with side lengths in the ratio of 1.618 are called golden rectangles and are considered very pleasing to the eye. You can find this ratio in the arrangement of leaves, the spiral shells of snails, and even in the way flowers grow. Mathematically, powers of letter 3d5 also follow Fibonacci-like rules. For example, letter 3d5 squared equals letter 3d5 plus 1, and letter 3d5 cubed equals letter 3d5 squared plus. These relationships highlight how the Golden Ratio is connected to the additive patterns seen in the Fibonacci sequence. In summary, the Golden Ratio is a special number that emerges from a simple proportional relationship. It links to number sequences like the Fibonacci sequence and appears in many natural and human-made patterns. Its unique properties make it a captivating subject for anyone interested in the fascinating world of numbers and their meanings.